Hello, welcome to the second video in the SAT Math series. In this video, we're going to cover some strategies and some notes on timing. The first strategy we're going to cover is an overwhelmingly popular strategy when it comes to SATs, and that is to work the problem backwards through the answer choice. This in many cases turns very hard problems very easy and avoids the trickiness of the problem. Secondly, we'll see how to get around some algebra by working backwards through problems using our own numbers when we can't plug in the answer choices directly. Lastly, an essential skill for math, and particularly standardized test math, is to be able to express a relationship algebraically. Then when it comes to timing, we'll note that you need to skip hard questions in favor of making sure you have enough time for easy questions. And we'll note that there's no guessing penalty, so make sure you fill in the entire test. As always, if you find the pace too brisk, please pause or slow down the video as needed. So it is the case with many problems that simply testing the answer choices or working the problem backwards is much easier than solving it the way they perhaps intended to be solved. Consider this problem here. A landscaper is designing a rectangular garden. The length of the garden is to be 5 feet longer than the width. If the area of the garden will be 104 square feet, what will be the length in feet of the garden? So it's a little easier just to try these answer choices and see if they work out, as opposed to solving this perhaps the way they intended to be solved. For instance, if these answer choices are the length, and the length is 5 more than the width, then we can easily get all the widths by just subtracting 5 from all the lengths. And if we do that, we can multiply the length times the width to get areas. And we can very quickly see that answer choice C is correct. The way this is intended to be solved, and it would be solved if it was not a multiple choice problem, is to formulate a system of equations using the two facts that the length is 5 more than the width and that the area, which is the product of the length and the width, must be 104. We will cover this in a later section, but it's important to note the strategy now of simply plugging in the answer choices if you're able to. Here we see another problem that could be kind of difficult, but is very easy if you simply try to work it backwards. It reads, if a is equal to 2, what is the solution set of the equation above? And it's complicated somewhat because we have x's trapped inside square roots and x's outside square roots. But we can very simply check these answer choices to see if the equation is solved with these as correct answers. For instance, checking 3 here, plugging it in, we notice that we have a equal to 2 here. We check to see if 3 works, and we find that it does not, because the square root of 1 does not equal -1. And already we've eliminated A, and in fact C. Trying answer choice B, which is 2, looks like this. And we find that answer choice B also is not correct. And eventually retry answer choice D. That's all that's left. And we see that that is going to check out. The square root of 6 minus 2 is going to be root 4, and that is indeed equal to 2. If you didn't have multiple choice here, the way that this is intended to be solved is by squaring both sides. But algebraically, squaring both sides has the ability to introduce additional solutions that are untrue to the equation, so you still, in the end, have to check your answers back with the original. We will cover this in a later section, but it's a good example of how much easier the problem is simply checking the answer choices or working it backwards. Oftentimes, you're able to work problems backwards not through plugging in the answer choices per se, but just by trying your own numbers in the answer choices. For instance, for number 10 here, it reads, which of the following equations has a graph in the xy plane for which y is always greater than or equal to -1? So they want to know for every single value of x, one of these equations always has a y that is greater than -1. Without knowing what the graphs of all these looks like, you can say, try something very easy, such as x equals 0 to start. And if you plug in x equals 0 into the first equation, the absolute value of 0 is 0 minus 2 gives you a value of -2, which is lower than -1. A is already eliminated. And if you do this with the rest of these, you would get the following. So this is at x equals 0. And actually, the simple choice of x equals 0 already eliminated 3 answer choices, which was kind of lucky, but this is just illustrating the strategy. The way they intend you to solve this problem is to understand how all these graphs look, and to understand that c is the only one that won't have any values below the line y equal -1. And this is perhaps what you'd want to do if you understood that you could do this and were ready to do this approach instantaneously. But if you're stuck and you don't know what to do, a lot of times you can simply try values like this and perhaps converge on the solution. The final strategy is more of just a math skill in general than a strategy, but it's definitely worth mentioning. That is the ability to always formulate algebraically what you know to be true. For instance, in this problem reads, in the figure above, what is the value of x? One thing we'll cover later is that all of the interior angles of a four-sided figure must add up to be 360 degrees. These things here are, of course, the interior angles. So we can formulate that the sum of the interior angles, there are 3 x's and a 30, must be 360 degrees. And then algebraically, we can very quickly solve this problem. This particular skill will be very useful when it comes to word problems and with system of equation problems. For instance, here it reads, in one semester, Dave and Sally spent a combined 410 hours in the tutoring lab. If Dave spent 30 more hours in the lab than Sally, how many hours did Sally spend in the lab? And if we simply say that D is the number of hours Dave spent in the lab, and S is the number of hours that Sally spent in the lab, then we see that D plus S must be equal to 410. And this representing this fact here. And our second fact would be, if Dave spent 30 more hours in the lab than Sally, so we see that we need to add something to Sally to equal Dave, since Dave spent more. And then when we get to system of equations, we will go over how to solve this. You can solve this through substitution or elimination, but we'll leave that for a further discussion, or later discussion. So throughout the entire course, we'll refer back to these strategies, and in many cases, we'll turn a hard problem into a very easy problem. Now, to talk about timing a little bit, all problems are worth the same amount, and you don't want to sink a lot of time into a hard problem. You don't want to be doing the test with the mindset that you must answer every question in the order that they're offered. If you read a question and you immediately know it's not obvious how you're going to proceed, you probably want to skip that question and save it for later. If you're somebody who seeks a perfect or near perfect score, this should only happen to you up to maybe 1 or 2 times every section. This has been my experience. But if you just want to be an above average score, perhaps you can skip, say, 6 questions every section, depending on the size of the section, of course, since there's 2 different math sections. But long story short, you want to make sure you have time for every question that you're capable of answering. Secondly, there's no guessing penalty anymore in the SAT. There used to be. Therefore, you will not leave anything blank, and worst case scenario, if you're running out of time and there's only a minute left or 30 seconds left, you need to be bubbling in something for every answer choice, just to have a chance to get it right. Lastly, a study recommendation, especially for those of you who are trying to get a perfect or near perfect score. Make your own record of all of your mistakes and misunderstandings. It's difficult to study and then run through a book or run through this entire SAT series and to remember the things that you need to review again. So if you just write down or somehow take notes or whatever on what you need to review multiple times, it will you'll get better bang for your buck when you come back to review again, because you're reviewing the things that weren't obvious to you the first time. Okay, in the next video, we're going to do a quick algebra review. Again, I'm going to post a separate series with a more lengthy discussion of algebra fundamentals. Okay, I'll see you in the next video.